All right, let's dive in. Today, we're going to get our hands dirty with one of the most fundamental tools in network security, access control lists, or ACLs for short. You can think of them as the smart, rule-based gatekeepers for your entire network, making critical calls on every single packet that wants to pass through. So, have you ever wondered about that? You've got this router, right? It's sitting at the crossroads of all your network traffic. How in the world does it decide to let your web request go through but slam the door on some other kind of traffic? Well, that's the exact question we're tackling today. And the answer? It's all about the powerful logic of ACLs. So let's break it down. Okay, here's our game plan. We'll kick things off with a simple analogy, the network's bouncer. Then we'll get into the real nitty-gritty, the logic of the list. After that, we'll compare the two main types, standard versus extended. We'll also cover traffic flow, inbound versus outbound. And finally, we'll put it all together to talk about strategic placement. Right, so section 1, the network's bouncer. Let's start here. Just imagine your router's interface is the door to an exclusive club. The ACL, that's your bouncer. The bouncer's got a list, he checks your name, you're on it, cool, come on in. You're not? Sorry, not tonight. At a basic level, that is exactly what an ACL is doing for your network traffic. Okay, so let's get a little more formal for a second. An access control list is, well, it's pretty much what it sounds like. It is a sequential list of rules. Permit this, deny that, and we apply this list to a router's interface. This is our go-to tool for filtering traffic and making sure our security policies are enforced right there on the hardware. Now, this is where it gets really interesting. It's not just about the list, it's about how the router actually reads the list. And this is the part you absolutely have to get. It's not random, it's a very strict, top-down process. Understanding this logic is the key to writing ACLs that actually work the way you expect them to. Picture this, a packet arrives at the interface. The router immediately looks at line 1 of the ACL. Does this packet match the rule on line 1? If the answer is yes, boom. The router does what it says, permit or deny, and the story ends right there. It doesn't even bother looking at the rest of the list. But if it's not a match, no problem. It just moves on to line 2, then line 3, and so on, all the way down until it finds a rule that fits. Okay, but what if? What if the router goes through the entire list, line by line, and gets to the very end and nothing matches? This is where probably the most important rule in all of networking security comes into play. At the end of every single ACL, there's this invisible, unwritten rule that says, deny everything else. We call it the implicit deny. It's simple. If you didn't explicitly say yes to a type of traffic, the answer is a big fat no, period. So let's look at a real example here. This shows that logic perfectly. You've got two lines. Line 10 says to deny traffic from a specific network. So if a packet from that network shows up, it hits line 10 first, it gets denied, and that's the end of the story. But what if a packet comes from literally anywhere else? Well, it won't match line 10. So the router moves on to line 20, which says permit any. And just like that, the packet is allowed through. See? The order is absolutely everything. So now that we've got the logic down, let's look at the actual tools. ACLs really come in two main flavors, standard and extended. And the difference between them really just boils down to one thing, how specific or how granular you can get with your rules. Standard ACLs are your simple, quick, and dirty option. They look at exactly one thing. Where did this packet come from? That's it. Just the source IP address. It's like the bouncer who just glances at your ID. Now, extended ACLs, these are the real powerhouses. They can check the source IP and the destination IP. They can check the protocol like TCP or UDP. They can even check for specific port numbers like port 80 for web traffic. This is the detail-oriented bouncer who's checking your ID, asking who you're here to see, and looking at what you're trying to bring inside. It just gives you way more precise control. Okay, so we know what an ACL is, we know how it thinks, and we know the different types. Now we've got to decide how to apply it. And that decision is all about the direction of the traffic that you're trying to control. And to see what I mean, let's use this sample network here. Now here's a mistake a lot of people make when they're starting out. You don't just slap an ACL onto the router itself. Nope. You apply it to a specific interface on that router, like one specific door in or out. And on that door, you have to choose a direction, inbound or outbound. First up, let's talk about inbound. An inbound ACL filters traffic the very moment it tries to enter an interface. So in our diagram, traffic from PC1 comes into router 1's G0/0 interface. An inbound ACL here would inspect that packet before the router even has to waste a single CPU cycle thinking about where to send it. It's like a checkpoint right at the entrance. And then you've got the opposite, outbound. An outbound ACL waits. The router does all its work, figures out the path, and then, right as the packet is about to leave through an exit interface, the outbound ACL acts as a final checkpoint. In our example here, the packet is on its way out of router 1, heading towards router 2, and the ACL on S0/0/0 gives it one last check before it's gone. All right, this is where it all comes together. The final, and I'd say most strategic part of all this. We know the what, the how, and the which direction. Now we need to figure out the where. Because with ACLs, placement is absolutely critical for both security and efficiency. And luckily for us, there are two really solid rules of thumb that guide just about every decision here. For those super detailed extended ACLs, you want to place them as close to the source of the traffic as possible. But for those simple, blunt standard ACLs, you do the opposite. You place them as close to the destination as possible. So why the different rules? Well, it all comes down to being efficient and precise. An extended ACL is so specific, right? You can use it to block one type of traffic from a source without affecting anything else. So you put it close to the source. Why would you want to let unwanted traffic cross your entire network, eating up bandwidth, only to deny it at the very end? That makes no sense. Block it as soon as it shows up. But standard ACLs are different. They're blunt instruments. If you place one too close to the source, you might accidentally block that source from getting to other places it should be allowed to go. So by putting it close to the destination, you make sure you're only blocking its path to that one specific place. Okay, let's wrap this up with a little thought experiment that puts everything we just talked about to the test. Let's say you need to let PC1 access a web server on a different network, but, and this is key, you have to block it from accessing anything else on that server's network. Now that you know the difference between standard and extended, inbound and outbound, and the rules of placement, what kind of ACL would you use and where exactly would you put it? Give that some thought. If you can figure that puzzle out, you'll know you've got a really solid handle on the power and strategy behind access control lists.